Hello, we are the group number 2. We'll be starting with the first question, which is to describe the concept of the EIP, so Industrial Affiliate Programs, and the different partners within it, as well as describing it on a concrete example. So first off, to start on the general topic, the IIP concept is a collaboration which functions on the basis of innovation ecosystems, which include partners from various positions in the industry who cooperate together. So it holds both competitor, it holds both complementars, it holds different partners which work together to develop certain IP which is available to all ecosystem partners in various options. So such things allows them to build their own unique IP, which is then researched together and which can be shared together. That is quite useful, as generally such joint research activities are costly, they involve high risk, they're quite complex. So it is useful for all the parties which are included in it, because it is cost sharing, it is risk sharing, and also it is talent sharing, as all of them from various parts of the industry bring their own knowledge and their own talent. So it generates generally applicable knowledge technology, so IP, which can be shared with partners to various degrees, as will be shown in the later slides. It is usually based on bilateral agreements with companies. So they have agreements between them, which then show how they share it and how they decide to research and to develop this IP. And most importantly, all the partners within it have a possibility to benefit from it. So there is something for all of them in it. So now we will move on to the second part of this question, and Andreas, who will show you how this is applied on a concrete example.
So this example is for 3D semiconductor manufacturing, and as mentioned, it has partners from all parts of the value chain, so that we can all sort of get solved the different issues at hand. For instance, the end users, they are there so that they can sort of represent their views on what is needed from their side on the design side. And then you also have the electronic design automation vendors, sort of they sort of supplies the interface between the end users and the original subcontractors that actually do the manufacturing. And then you have the subcontractors and test companies that do silicon processing, that part of it. And then you have the equipment suppliers and material suppliers that supply the needed materials and to the original subcontractor test companies for actually doing the manufacture, so that the full value chain is represented, so that you get a good end products. Okay, so next.
So let's describe the core IP management principle in order to simulate collaboration. The most relevant points here are about ownership and access rights. But before we discussing the fourth position, we introduce two definitions. IP background, which is the IP existing before the collaboration, and IAP foreground, which consists of IP outcomes of the research. And then you have first of all, for each partner, to a payment of an entrance fee, and then they are able to have access to IP in several manners. So we distinguish three types. R0, which is collaboration between the IMEC researcher without industrial residence. In this case, IP is owned only by IMEC. And about access rights, you could have a non-exclusive, non-transferable license for if you are an IIT partner. In the second case, R1, in fact, here you have a collaboration between IMEC researchers and IP partners. So in this case, you will have co-ownership of the IP and different kind of access rights. Each of the co-owner can use the IP as they want. And if you are not an IP partner, you will be able to have a bilateral agreement. Depends on the needs you have on this technology. Then for you have a specific case, which is the R1 star. In this case, IP is developed by an IP partner, but with no share with the all others, because you will have a competitive reason for that. But in this case, you will be able to share general knowledge with all the partners. And about ownership and access, IP is co-owned by IMEC and the industrial partner. And the last one is R2. In this case, the IP partner wants to perform only limited proprietary research. Sorry.
So the last question was essentially relates how IMEC dealt with the problem on how to ensure business continuity in this role of orchestrator, being an orchestrator in the semiconductor industry. And in the semiconductor, so basically, how can they extend their business model besides focusing on the current activities, but also predicting future activities where the same or similar model can be used, and essentially anticipating disruption within this business model. And in the semiconductor industry, there's the Moore's law, which essentially says that the number of transistors double every 2 years, and there are two diverging trends nowadays. One is the more of Moore, so basically continue as before, try to make smaller transistors, and that is where most of the current orchestration projects of IMEC were based at the time. So of course, IMEC would have continued to do that. But at the same time, because this is a very complex, very expensive process, a lot of end users actually diverged from this business model and follow a different trend, which is called more than Moore, by actually integrating more functionalities inside a chip and making, for example, a system on a chip. And this now leads to a different type of potential collaboration possibilities where the emphasis is actually not given to the pre-collaboration before going to the market, to rather focusing on collaboration closer to the market, which essentially changed the ratio of IP of the contents of the IP total IP portfolio of the group. So moving more closer to R1 asterisk and R2 compared to R1 and R0. So to more exclusive rights, and less shared IP rights. So this is one trend that IMEC look at in order to ensure continuity of its business model of orchestration. Another thing that IMEC did was to leverage their knowledge or in life sciences, and actually make an horizontal collaboration or orchestration collaboration with different type of partners who would benefit from the experience of IMEC and its semiconductor industries in chip manufacturing in order to deliver medical products. But as these partners will benefit from the experience of semiconductor manufacturers as partners, same partners will benefit from the experience of companies in the biotech industry or life science industry in order to integrate biotech functionalities into their chips. So basically, because IMEC didn't have experience as such in orchestrating this type of consortiums, they made a horizontal collaboration with a different partner, orchestrating partner this time. So essentially, the takeaway of this teaching is that it is possible to collaborate. Collaboration between collaborators, it is possible, can be used as a competitive advantage by sharing risk and increase the speed and transfer capabilities.